So first of all, did you guys have any problem with the last lecture? Like, because I couldn't finish all the slides. So did you try to understand or any question from the last lecture? Anyone? So should I assume that everything was understood? Okay. Okay. So our third lecture objective is we'll finish the system thinking from the last lecture because I skipped something, and if still there are some questions, we'll try to discuss in the class. And now today we'll learn something new, requirement engineer. So maybe this is pretty new for you guys, or I don't know. We'll discuss. Okay, let me go back where I finished last lecture. So yeah, I'm not in the presentation mode because I wanted to do it quick. So did you actually understand this slide? It is pretty simple, but there is some key points. You see, cup of instant coffee. So if you have a packet of coffee, instant coffee, then how you can actually make this coffee. Did you understand why the spoon is not included here? Cup, hot water, coffee, all right, cream, sugar. Do you have any clue like why the spoon is not actually included here?
Because you use the spoon from the outside of the
Yeah.
system,
Very good.
and you
Yeah, like shake it or
Yeah.
mix it. Yeah,
mix it, and then you put it away.
very good. Are you agree with this point? So you see, like this is very simple example, but when you can apply this simple method for designing a complex product, then this is really very helpful. And you see in the induction or what do you call bottom-up approach, they have almost same sort of things, but they actually organized in different way. This is not really complex, but why I put this to make you guys understand, like thinking in systematic way, like one after another. So not in chaotic way. Also, chaos has some sort of system inside. And sorry, I made a mistake. So did you try this one? Like to design something like this from the above example? Didn't you?
We make it today.
Okay. Thank you. Thanks for making me remember. So let's do it. What do you think? What we gonna need for So last lecture I told you, like dryer means actually many things. Like I don't know, hot gun also a dryer. Then how we are drying the clothes, that is also a dryer. So the name supposed to be here is hair dryer. So I intentionally made a mistake that you should ask the question. And let's see from the system point of view, like what do you think? Like what we need to design this dryer? What do we need? Or from the discipline perspective, what do you think? What we gonna need to design this hair dryer? how many engineers you need. So if somebody asks you like, please design, or if any company comes to us, maybe we are a company now, and they are asking like, you have engineers, so please make a dryer, a hair dryer, no? And of course, we have to ask so many questions, and that we learn today in the requirements engineering. So there is no specific requirements here. But normally, if you, thank you very much. Normally, if you want to design something like this, you see, of course, you need a mechanical designer, so who understand, like, we don't know, maybe it will be metal and plastic mix or only plastic, we don't know yet. Then we need a electrical engineer, because this will have some switches and some control system as well. So and if you really want to make this one like a IoT system, like Internet of Things, then maybe you can put some sensors and you can make an apps, and you can see the product status online, where you can make the product run through your apps. Then you need a software engineer or a IT specialist. So first of all, if we actually try to think from the top-down approach, so we need a I don't know, we need some sort of materials, and that includes like what do you call it? The structure. One thing, please bear in your mind, there is no right and wrong, and that I try to establish over first and second class, because in the first class I asked you guys to do something, and if you do that in the second class, you will see like the aircraft design one, you will see the difference from the first class to the second class. You will see the jump from the system thinking, like normal thinking versus systems thinking. When you already learned the systems thinking, you will see some sort of betterment. I didn't see your task yet, but I guess it will be better from the first one to the second one. I'll come to that point later on. Okay, so we need structure. What do we need next? We need electric circuit board and some switches. So I don't know, we can call it like electrical equipment or electrical parts. I don't know. For the next, what we need next? We are taking the outside air and we're making it hot. So what we need?
Maybe a thermal expert.
Yeah, not expert. We are talking about the specific parts right now. Yeah, heat exchanger. Yeah, maybe something like this. Okay. Anything we need?
To increase the pressure of the air if you want to.
That is actually related with the structure, and like the electrical parts. So this I will come later on. So electrical parts, maybe switches. Yes. Maybe we need switch. We need electric circuit board. What we do next? Okay. Yeah, I think we need a Yeah, so you see now the problem is coming. So we're gonna need a plug, or we're gonna need some batteries. Because you see, it depends on the, still it's coming to the requirement engineering discipline, because when you wanted to make some sort of thing like this, then you do not know what's the stakeholder wish. So you have to think, yeah, if it is for like travel purpose, so somebody can put it into their luggage, and like normally when we are doing luggage for the travel, so is smaller is the better. So then again the question comes, how big the structure will be. So you see, tons of questions are coming, and how you gonna tackle those questions, we're gonna find the solution into the requirement engineering part. So heat exchanger, anything else? So maybe we can call another one here, this electric plug. Anything else we need? So we need one more thing, is like the switch and the controller. So the switch is not the controller. Maybe you can combine this one, but I don't know. We can write it separately. Controller. Anything? We need a motor, because without motor you cannot really suck in the, and you need a fan. So motor plus fan. And here is the tricky part of systems engineering. If you divided the parts based on the discipline, then you see motor also has a structure. The fan, I think, pretty much fit with the mechanical parts, or with the structure, or the sub part of the structure. So you see, if you actually dig down deeper to the system, you will find, I think, more than 100 components for these small things. And you see, when you are thinking of a aircraft or a automobile, you see how many components or how many parts we're gonna come across. So that's why actually we need, this top-down and bottom-up approach. And the top-down and bottom-up approach is more or less we are doing our daily work also with those top-down and bottom-up approach. And how you actually, these are the components, and how you gonna manage this one, how you gonna structure or make a system architecture, that we will learn actually slowly. So I do not want to actually spoil the whole time by making this one. So I'm just bringing this example here to show you how you can think systematically, and maybe from the views of discipline, or from the views of system, subsystem, or components level. So, any question here? Any ambiguity? Okay. If not, then I would like to skip this one. This is actually something related with our how our brain actually functions. And this is system thinking perspective. So when we are doing system thinking, we have to think of a big picture, like, where the systems of systems come across, systems environment, and, all the thing, what actually somehow influence the system's functions that we need to consider. And system thinking actually have different parts. So it's operational, functional, structural, generic, continuum, quantitative, scientific. So this is quite boring to me, but it's good to know. And different people describe systems thinking or doing systems thinking differently. So the point to bring those things here that you should know how the systems thinking actually work. Okay. So this is a little bit more description and examples of those things what I described before. And okay, this one, did you do anything on this? This was actually the homework, right? So did you think or no? May I see? Or please feel free to come here and we should discuss. So this is not a place for, like feeling shy or something. We are all learning, I'm doing.
Yeah, I can tell you because
Yeah.
I just took the slide before.
May I write? If you tell them, may I write? Then things will be more visible for everyone.
Yeah, the big picture I think is it's a transportation vehicle.
Yeah.
Like an all-rounder vehicle for driving, but also for flying.
Mm-hmm.
Because I think it's an air vehicle.
Mm-hmm.
Yeah, the operational aspect could be because I watched the YouTube video which was
Mhm.
the link for business aspect just like camp.
So you found already the operational aspect of the product, right? Very good.
It could also be like ambulance,
Yeah.
like a helicopter.
So air ambulance. This is more feasible, like normally when you're gonna do the requirement engineering, then this part actually, this operational view actually call the use cases, like what purposes your product will be used. I'm just try to connect, then yeah. Then structural, functional.
How many seats it should have, or
So I would say not seat, I think capacity.
yeah. For the structural, or the aerodynamics of the vehicle should look
Yeah.
like, or how should it be navigated?
Mm-hmm. So structure,
Aerodynamics, or
aerodynamics is not really directly but it somehow, I understand what you meant, but it's supposed to be something else. So what it is showing here. So the structure, how the system is constructed and its elements are organized. So here maybe you can call that semi-blended body. I think in the video they already said, right? Semi-blended boxing body.
yes.
So this is one of the feature. Okay, then generic. It's amphibious aircraft. So yeah. Okay, then continuum.
The differences to other existing.
Yeah, so it is pretty much same to me, but you can also write the small aircraft actually called general aviation aircraft. So the bigger one is normally calling the commercial jets or commercial aircraft. So yeah, so general aviation. Okay, temporal evaluation of house over time, so maintenance and repair and extension. So I don't think so. They talk about anything.
No, but it could be first there was the car and the airplane,
Yeah,
and maybe a helicopter and
yeah,
the drone. Or
yeah. Uh, yeah, this is somehow related with the functionality as well, and I think it's hard to distinguish even. You see, the point why I gave this task. Most of the time when we learn the theory, we think like we will apply 100% into our practical life, but in practical life it is not really fitting everything, so you have to have this sort of understanding over this course, that you will know what to add and what to extract, so what to delete. So this is the two thing you need to be like you should learn from this course. Okay. Then I think others are not really like so important, because we'll learn some of the tools during this course, and I have written this tools name because they're really very important thing when you are making some sort of decision, because most of the time we are making decision based on our observation or any kind of calculation. So these tools actually help you to make right decision. And most of the time, let's say when you wanted to write a publication or your bachelor thesis or master thesis, you have to show some reason behind that. And I think you can also use these tools in your bachelor thesis or master thesis as well, or if you are really in the scientific realm, then writing scientific paper also, these tools help. Um, okay, so this is the system thinking type. This you already know. And this is the critical thinking, what we are discussing a little bit in the last class. So critical thinking is not like is not used in the systems engineering world. Rather, it is using academic world, and we talked about a little bit. Do you have any question in this slide? No question? Okay, then I can go to today's one. Okay. So, requirement engineering. Did you heard about requirement engineering before? Any of you? Any case? What is it? Do you understand like what is requirement is? Um, this is a caution. Don't mix the need and requirements, because they are two different things. Previously, I was mixing things, and mixing because different books or different publications, they are describing those two differently. So needs and requirements are not really same. I think it's better to distinguish between them, because sometimes Yeah, they are telling like stakeholder needs, but requirements normally, what I understood is like what's the system's requirements are. And this is actually the last phase of systems engineering, and we'll learn about this. So if you consider the requirements engineering. So the requirements engineering has two parts. One is requirements, another one is engineering, right? So requirements is basically the stakeholder needs, wishes, whatsoever. And um, there is also a definition. And engineering is like when you are doing something systematically, it has some what do you call analysis behind, then it is more or less it's calling engineering, or maybe you can follow some sort of framework or methodology, then it is goes under the engineering realm. And if you see the what do you call this graph is quite interesting here. You see the requirements added, deleted, or modified. So if you consider the whole life cycle of the product, they are not actually showing the whole life cycle, because after design and development, yes, sometimes during the manufacturing, you will see some bad experience with the cars, like in US market or European market. Sometimes, some car manufacturer, they're, sold the cars, and after they took it back because something was wrong, and yeah, it is disastrous. So sometimes the requirement engineering actually goes to the operation part as well. You see translation to the operation. So they actually try to show how the number of percentage, how the requirements are changing over time. And you see, it is a continuous process. So as an example, um, in my first year of PhD, there was a company, Austrian company called Promote Automation, and they're actually working with the KUKA robot and robotics. So I was asking them, like, how you are gathering the requirements, and during one of our meeting, how you are gathering the requirements, and when you know that the requirements is finished. And the I don't know, it's Geschäftsführer is the MD, right? So the MD was telling, like, he's really like a very knowledgeable guy. He was telling it's mostly never completed, and like the customer would like to change the requirements over time, because customer, when, or the stakeholders, when they create the requirements, they do not have the full view of the requirements. And why they do not have, we'll slowly learn from the other slide, because there are really too many slides for requirements engineering, and it is not really a small topic. I think the baseline of model-based systems engineering is requirement engineering, because you have to learn everything about your product here. And as soon as you are good on your requirements, your product success will be higher. So here it is estimated that around 68% of the project fails due to poor requirements engineering. 68%. So this is really huge. And the industry average investment in the requirement process for typical system, 2 to 3%. So let's say if your total project cost, like, I don't know, 1 million, so around 20 doesn't gonna be spent for only for the requirements engineering or for the requirements gathering or requirements solicitation. This is really very important. And why this is important, when you're gonna perform your assignment, you will see why this is really important, because it links with your whole product life cycle. It goes from beginning to the end of your product. Okay, so requirement in a what you call, in a general view, requirement is supposed to capture the product context. So let's say if we consider a coffee, um, it's supposed to capture what's the function of a coffee and the behavioral aspect of coffee and the social aspect and the emotional aspect. So this is somehow very much engineering topic, and this normally we are calling the functional requirements, and these are more or less non-functional requirements. And most of the cases, non-functional requirements are not verifiable. And there will be one class only for the functional architecture development. So there you will learn why we need to think something based on function. And this is a very ongoing topic. And Professor Seman and me was writing a paper since 4 years, and it has not been finished yet. I will show some slide also from this publication. I think one slide is also here. Requirement should answer the functionality, performance, constraints, attributes, external interfaces. So how many of you can remember the first lecture when I have shown the systems, then subsystems, then component, then there is environment, then there is a systems of systems, and then systems of systems supposed to interact with the outside of the environment. So this is pretty much describing the same way. So if you read it through, it's quite explicit. Any question here? If no, then I can go to the next slide. So what's the goal of a requirement? Different people actually think requirement engineering has different goal. Why I'm writing RE is normally the requirement engineering is in short form called RE. So I'm not really fully agreed, because the water is not really good, because normally in requirement engineering, as I have told you already, first you have to understand the needs of your customer, then you can create your requirements. But here you see, like, knowing the relevant requirements as achieving a consensus among the stakeholders about this requirement, document them according to given standard. So this normally, like, these standard things and everything does not comes when you are talking with your customer for the requirements, because requirement could come as a phone call, could be like it is the duty of a systems engineer who is actually writing the requirements, that every time he's supposed to capture the requirement, maybe from the discussion, maybe the customer went out for a coffee, and they're discussing something with the product, and they immediately they think of something and they're asking, this could be included into our product. So what I understand is, like, understand the stakeholder needs, know the relevant requirements. Like, from the needs, you have to convert those needs to requirements and document them methodically, that it has a you should prioritize the requirements, because in every single requirements are not important like the other one. Let's say the engine is not, if you consider a aircraft, and the engine is not same important as the landing gear. You understand that? Because different parts have even though when we are studying the aerospace, there are also some, we heard about this one, minimum equipment list. Like when you wanted to take off the aircraft, then the pilot's supposed to pilot and also the purser who are serving in the commercial aircraft, they're supposed to ensure the minimum equipments, like maybe in case of disaster, what sort of things supposed to be there. They have to make the checklist, and they have to ensure that those equipments are there. So methodically document them means, like you have to put them everything in order and manage them purposefully. So only, it is not important that you are writing the requirements, but you are not managing them, because as I have showed in the first slide, requirements actually goes from very beginning to the operation of the product, right? And if you do not have a systematic way to manage them, then I think you will sink yourself into the requirement sea, because this is like really, like you see, only a single thing what we wanted to make the hair dryer. There are so many things are coming, start to coming, and I actually stopped there because it will make me crazy. So that's the thing, you have to be also careful. So this is more or less the same thing what I told. I like his way of thinking, and yeah. So the requirement supposed to be the customer acknowledge that the system meets their expectation. So with the requirement engineering, we try to deploy the specific product what the customer actually wants. Tasks and project requirements are complete and controlled to provide a stable basis for the development. So, based on something, you have to start your work. So this part actually give you this idea. An informed marketplace is developed where potential suppliers' ability to define, implement, and support requirements based development is valued. This is also very important. When you should not only think of your customer only or stakeholders. Yeah, stakeholders also include. There is also one slide about the stakeholders. So it is not about only the customers, rather one product or complex product you cannot manufacture without having help of the suppliers. Let's say if you are designing a aircraft, maybe you are not designing the engines, so maybe you have to buy the engines from Rolls-Royce or General Electric. So they also supposed to understand your requirements. So you supposed not to make something that they have to invest their time and making something very new that actually increase your product development time and cost. So the key thing is you also need to consider your suppliers during the requirement engineering phase. Okay, so this is actually the product development phase. If we consider the PLC as a binocular, and you see it is very early age, early part of or early stage of the product development phase, where you see the product planning and product development and requirements design or requirements engineering, and it has the functional design, physical design, verification of the requirements. So this is actually interlinked, and if you are, this is only this part I described, and you see so many steps you have to fulfill before going to the production. So this is the production phase or assembly phase. So you see the importance of requirement engineering, and this whole part is under requirement engineering. So it's really huge. Then major types of requirement engineering. There are really, honestly speaking, there are many types of requirement engineering, and I just mentioned few, what you will hear every time. So user requirements. So we talked about the problem domains, and the solution domains is the system requirement. If you can remember from the second lecture, one slide was like this. So functional requirements and non-functional requirements. So the guys who are working with software engineering, this is, I think, very common terms for them. And also for us, because we have to deal with everything, mechanical, software, electrical. So systems engineering is the mixture of almost everything. So there are some major categories from the ISO 9001 also, but ISO is always very confusing because they try to cover everything, and yeah, most of the time you will lose the direction, like what they are really talking about. But one important thing from the ISO 9001 is the criticality of requirements decreases as we move from the regulatory to the standard requirements. The requirements in the lower order should not violate the higher order, especially regulatory requirements. So, do you have any idea what could be a regulatory requirement for, I don't know, for the hair dryer? Any guess? Maybe there are some requirements from the regulatory for the home appliance. Maybe there are some guidelines from the government or from, I don't know, from the ISO that the heat, let's say, how you are heating the hair dryer. Let's say this heat actually goes to your head, right? Or someone's head. So there is a specific temperature a person could sustain, right? And maybe there is some guideline that if you wanted to use this, then this is the maximum temperature you can create in your system. So so the whole thing about here, what the ISO tried to mention, that requirements as water, like the bigger requirements to small requirements, how the main system to subsystem to component. So every single level, we have to be conscious that when we are making the sub requirements, that these sub requirements are supposed not to violate the top order requirements, right? And and somehow you supposed not to make something that the regulatory requirement is also violating. So this is some of the ISO 9001 requirements part, and they have, I think, more than 30, if I could remember. So if you are interested, I also can upload those documents, or you can search it. It's freely available. So now the major phases of requirements, and it is also a little bit confusing. because different people also think different way how the phases would be look like. So I took two different examples. So one is from a book, one is from a publication. So first, this is I think this is from a book. This is first phase is plan the requirement, then establish the requirement infrastructure, then elicitation the requirement. So requirement gathering is not requirement elicitation. So elicitation is something different. So did you come across with this word before? So, okay, you will learn this. And then you will create the specification, then you have to manage the requirements. So these are the main parts. And there is a graphical presentation here. So plan, establish, elicit, analyze, and manage is actually from the beginning to the end. And the most important part, from my understanding, the elicitation and manage the requirement. So this two part is the most important part. So I will give you a small overview on that, because every single part, if I wanted to discuss, it will take actually whole course. This is really very big. This is the second approach. What the other people also think, what's the parts or what are the steps of requirements engineering. So they bring elicitation, analyze, specification, verification, and validation. So this is very important. The verification and validation. Am I designing the requirements right? And am I designing the right requirement? So there is a specific difference between the verification and validation. So the goal of requirement validation is therefore to discover errors in the document and correct them. So this is actually the verification and validation. This is somehow related with the analyze part, you know. So this is the same thing, but they're talking in different way. And here, one thing. From my personal experience, I'm always mixing the requirements verification and validation to the overall systems verification and validation. So this is totally different. It is not same. Here we will see that the requirements, what we have created, is it right or wrong? And here we have tried to validate what the requirements we have created, is the system is fulfilling those requirements or not. So this is the biggest difference. And normally people confuse with V and V verification and validation. They think like it is same for everything. It is not. Okay, so this is the another one: elicitation, analyze, specification, validation. So this is another way of thinking. So could we create a process here, like, you know, to mix these two? I also could create, but to have some sort of brainstorming session, I didn't do it. I thought like if we could do it in the class, or if you wanted to do it as a homework, I would say that would be better, because I don't think so we have enough time. So what do you think, which way we could move? Would you like to take this one as a homework? But yeah, if you guys wanted to do at home, then take it. Other than we can do it here. Maybe I will take another class for requirement engineering. Because you will have some time to think of. This is the key part of requirement engineering. I would say if you understand this, you can easily do your first assignment, and I think with the engineering work, life will be really easy when you understand the steps. Because normally, you know, our brain works with chronological order, so one after another. So it makes it step one after another. So if you understand the whole concept behind it, you have to understand the the sequences. Would you like to take this one? Because this is only the 4 slides. There are 2 types of mm, phases people are telling. So you have to make, and the description also there. Can you try this one at home, and we come back into the next class and see? We'll give our reason why we think in this way, this is the right, and this is a open discussion session. I think it's better, then you will have some time to think of what is requirement engineering and what are the steps. Yes or no, guys? If you are not happy, then we can do it. So, okay, homework. Yeah, it's fun. Like, don't think as a homework. This is like learning how to handle the requirement. So I because normally when I heard from the lecturer or from the professors, like, yeah, I have to do this at home, and I'm not really very happy about this one. But this kind of thing is really very different, because if you run it properly, you can apply it everywhere. This is the magic of systems engineering. Okay, so as I have told you, there are 2 key things: is the verification, validation, and the requirement elicitation. So I just give you a small overview how this actually works. So there are 3 quality aspects of requirements. So the content, documentation, and agreement. Because this is the content is related with the elicitation. Like, normally before starting your requirements gathering or requirements elicitation, you have to prepare some sort of documents, how you will gather those requirements. And I will show what are the key part of those documents in a nutshell. And based on those documents, you're gonna, because why you need a proper documentation. Without proper documentation, let's say when it goes to another person, he will not understand where from this requirements is coming, and yeah, the time, date, who actually proposed this requirement. So all the things are included there. And principles of requirement validation. This is just only for your understanding. So, but the key things is these 3. I actually put some extra things into the slides, because when you guys gonna read it through, then you could understand easily. Other than if I only make the slide like how I understand, then I think when you're gonna use those, it will not have any explanation. So that's why sometimes I'm putting a little bit more information, that later part you could understand it. Okay. This is a famous publication. I think I really like this publication. It's 6 or 7 pages. It's a conference publication, and there they wrote like what the characteristics of your requirements, or how you will understand that your requirements is good requirement. So first, you have to see that really the stakeholder need this or not, because sometimes when we start to write, we try to write many things, and sometimes when we have written things, it's hard for us to delete something and making it short. So Yeah, you have to have some sort of agreement with the stakeholders that this is the specific thing what they actually need. Then the verification, your requirements supposed to be verifiable, and this is not true for every cases. I can give you an example. Let's say a non-functional requirement is most of the time not really verifiable. Let's say if you designing a car and one of the requirement is the car aesthetically good, so aesthetic means like in terms of the beauty of the car is better than other cars. Is there any way to measure it? There is no way. So try to, when the customer asks this kind of question, then I think also you will have some sort of question like this in your first assignment. So but you have to ask your customer with this sort of non-functional requirements specifically, like which way you wanted to see the car. Then maybe he could tell many things, but maybe you can bring like it will look like Tesla X model or Porsche. I don't know any other model of Porsche. So some examples you try to bring into the board that you also will understand what's going on in your stakeholders' mind. Then attainable, of course. Every project when it starts, it has a time frame, it has budget. So you should not think something like very exclusive that maybe take I don't know 30 years to finish, and it is not attainable. Then I think the requirement is not good. Clarity. So clarity is something related with like how you're writing your requirements. Is it possible to understand from the second person who gonna read what you have wrote? So this is the clarity you need to establish and supposed to be unambiguous. So poor requirements characteristics. So normally when the poor requirements has been written, the customer are dissatisfied. System does not meet the requirements of the stakeholders. Then features need by stakeholders not need getting implemented. So normally these are the characteristics, and there are many, but I just put three. And this is, I think, a very cute example of how the requirements engineering fails, because you see how the did any of you came across with this picture before? Okay, but in aerospace, like this is one of the funniest picture we always came across. I think many lecturers using this image. So this is how the customer explained the need of the stakeholders. Like this supposed to be. What does it? What's the English of this one? Schaukel English? It's the English of. No, Schaukel is German, but I forgot. Like swinging, yeah, swings, yeah, yeah. And how the project leader understand this, so he wanted to put this one. And how the analyst or designer who is designing this, he understood like it's not possible to like the back and forth motion, creating back and forth motion. So he actually made something like this, and the programmer who is writing the code, he understood it's supposed to be like this. And how the business consultant, he understood that it is something like this, very fancy thing. And how the project was documented, so something like this. So there is no tree, no what do you call this, Schaukel. Again, I forgot. And this is what operation installed. So when it is installed into the system, then how it looks like, and how the customer was I don't know, built. Mhm. uh, how the customer actually construct this one. So they construct something like this, how it was supported like this, and what the customer really needed. They actually need this. And you see, like nobody actually understand the real need. And this is actually the whole process why we need something very clear, because it's not only you who is taking the requirements. It's numbers of engineers. As I have told you, like with this one, you see mechanical software, and last lecture I also told, like Sabine, my colleague, she took 6 months to understand what the other mechanical lady is talking about. So it is like information exchange supposed to be smooth and very specific. So that's the goal behind this requirements engineering. Okay, this is also like why poor requirements occurred. I think rather talking about this one, I think it is also possible to see this video, small video, but I found it quite interesting. Is there any sound? Hmm, I don't think so. Do you have any ideas? No. But it's quite graphically presentable, like what they actually wanted to see. What I described before, this is the same thing, like so this is the requirements that they are giving. Sorry, there is no, I didn't check the sound. I supposed to check the sound before. So how the, I would like to pause here. So how the requirements actually look like this. So this is the, what do you call, the traditional systems engineering way. And why we need to do the model-based systems engineering. Now we are not making any documents like this. So we are only using mostly SysML-based tools. And in the SysML-based tools, like, do you know the Agile project management or something? Do something, okay. So the Agile project management is something like your customer will be in the table, and you are taking the requirements and you are creating something in front of him, and telling, and there are also some sprint as well, and it has a really good way of doing the project management. So the whole thing is you have to do everything in connection with your customer or with your stakeholder. So your stakeholder is supposed to understand everything what you are doing. So when we are doing with the SysML based tools, those requirements, they are pretty easy. I will show you some examples, and other people also understand what you are doing. And when you are changing something, it also have some information, like who has changed it and why it was been changed. So you can capture all those information, through your project life cycle. So that's the reason, like why we need model-based systems engineering. This is one example. Without sound, it's really boring. So they're again changing requirements, and they're putting some new requirements. And they're talking about a software solution, and when it is going back and forth, and they're actually changing some requirements, making something new, and I think there's something new. So they try to show something like why the model is actually important. So time and cost. I think this is more or less almost finished. What they are telling, like, let me tell the whole thing because 4 minutes is too much. So the summary of the presentation is like, sorry. So it is similar like what I told before. If you have some requirements and that is not attainable and not manageable, then you are somehow losing your time, and yeah, and it costs a lot for the company. So they also try to sell their services. They have some sort of, like, initially you can prototype some software. Immediately you can show your client that this is the way how I am thinking based on your requirement. Is it right or wrong? Then you do not need to think of these big documents. Yeah. This is the overall outcome of why we need requirement engineering and how the poor requirements actually make a chaos. Okay, so verification and validation we have learned, and the elicitation technique. For elicitation, there are several techniques. I just put 4 of them. So survey technique. So survey technique normally, interviews, workshops. So this is a very common way of doing requirement engineering, or requirement elicitation. And creative technique, normally I already talked, like the brainstorming, like how we wanted to do the process, mixing the two and making one. Then document-centric technique, systems, archaeology, perspective-based reading, requirements reuse. Only the requirement reuse I know, but the other two I never used. Observation technique, I think this is the most used one, I would say, which is not only for the systems engineering, rather than our daily life, we are using this. We observe something and we understand, and we, implement, or we create the requirements. So factor influencing choices of elicitation requirements. So there are several factors. I sorted out some important factors here. So what are the requirements types? So desired level of details you are collecting during the requirement elicitation process. Let's say I will show you what are the details of the requirements. Then time and budget. So you're supposed not to create some requirement that is not really attainable. risks, availability of the stakeholders. You have to also think of the availability of stakeholders. Sometimes you try to think of something and make your on your own without consulting with the stakeholders. So the requirement supposed to be authorized by the stakeholders. Then risk of the project that has to be also analyzed during the elicitation process. Then the context, organizational influence. Organizational influence is something like every organization, there are some problems. Like, let's say we were talking about something like implementation in model-based systems engineering into different organization, and there we found like the higher authority, they actually do not understand what the model-based systems engineering and what's the benefit of it and how to implement that and what sort of workforce they need. So they hear everything and they said, yeah, I don't think we're gonna need it. But the other people who is actually doing the engineering work, they actually understand the problem, and they really want that. But because of the human behavior is something like we do not want to change something. We wanted to keep into the phase like until and unless it is not necessary, really not necessary. So organizational influence, like simple organization like the engineering department is not the everything of a company, right? So there are different parts of the organization. So there you need some sort of what do you call a harmony between the organization. When you are eliciting the requirements from the customer, then you have to hear everyone's aspect. Like you're supposed not to satisfy only one customer rather than the team of the stakeholders. Okay, and then requirement sources, where from you are getting the requirements. Most of the time from the stakeholders, and the stakeholders is really like related everyone who is involved in the whole project. And there are different types of stakeholders, sponsor, project manager, tester, end user, administrator. So everyone is actually a stakeholder. Okay, so another important thing you see here, there are undesired stakeholder as well, hackers, and who are doing fraudulent things. They are also stakeholders, because if you're developing some sort of IT product, then you have also think of this. Even though when you are designing a bicycle, you have to think of these peoples, because somebody could take your bicycle. So the thief could be one of the persons. It is not only for the software engineers, rather than is also applicable for us. So they are also stakeholders. So their things supposed to be comes under requirement engineering. Okay. So this is some guideline how to write a requirement. So there are some wording also. The shall, should, will, may, and the verbs. So I will upload these slides, and this is very easy to understand. So I will not spoil the time. Okay. So this is another part, like when you have object and additional details about the object and how you gonna write those. And this is also more details. So what do you call, like who gonna use this part is new, and then how you are adding the things. So this is quite interesting when you're gonna write requirements for the first time for the electric bike design. Then I think this actually helps you more, and it's easy to understand. So I will not discuss this part. Okay, here's a little example of model-based requirements documentation. As I already told you, like normally now we are not doing everything in pen and paper or MS Word or MS Excel. So we try to do with SysML-based thing, and where we documented the requirements like the goal, or I normally call this goal part is like the customer needs, and then I make system requirements, then I make use cases. So this order is not really like linear, so you can, but the first one is the goal or the customer needs are the first one, because those actually help you to drive those use cases and system requirements. And you will know this one better when you will start the enterprise architect, I think, from the next lecture with Sabina. And here is like how we're gonna write the goals and the what do you call use case diagrams. So this is a little example. Any question here? If something is ambiguous, like somehow I jump from the normal requirements to model-based requirements. So if you have any questions, feel free to ask. Okay, this is some, I don't know, you can see it or not. So this is actually made in Enterprise Architect. So you see, this is the higher level requirement, and this is lower level, and this is more lower level of this one. So what we have discussed before. So this is one of the example that you can see. But I think when I gonna send it this document, you gonna read it through, because I can read from here, but from the, I think the pixel are not really good. Okay, the same requirements, I made it with Cameo System Modeler. Yeah, I like actually Cameo System Modeler, because it's really quite easy to handle, especially for the requirement engineering part. So this is the way how, so here is actually the main requirements, and here the requirements number. And then you see, when you're writing something, it is not explicit, so other people could understand this part, you have a description part here. So this is the way how you are writing the requirements, and when you are creating a new requirements, it will take automatic numbers, and yeah, it's quite easy. So you do not need to, and even though this view you can change into Excel sheet, and you can verify one requirements to another one. So there are many possibilities as soon as you have this diagram. Okay. So now requirement hierarchy. So solution escape. This is another way how I told the goal, then use cases, and system requirements. Normally, this is the traditional way. Solution escape, the system mission or solution statement, what you actually wanted to do for the aircraft. I would like to see something like this, and high level or parent requirements. As I have showed you, like there are some requirements, and under there are some requirements and detailed or child requirements. So this is the hierarchy of requirements. And requirements management is like, from the very beginning of requirement engineering, you have to how you are documenting the requirements, and if there is any kind of changes you are making, then how you organize the whole thing. That's all about requirements management. And requirements management is supposed to have some attributes. So the unique identifier. So unique identifier means like the numbers what you're gonna use for one requirement is not same for other requirements. So this is very identical. And there will be name, there will be description of the requirement as I have showed you in the previous slide. Then also the sources where from it come, and who is the author who is writing actually the requirement. So those are the things you can capture now digitally. You do not need to make any kind of Excel sheet or something and fill it up manually. So now you can if you do things with system based tools, it's more easier. So this is prioritizing requirements. So you also need to, as I told in the very early in the lecture, that all requirements are not same important. So there are some levels. So the requirements prioritization could be based on those criteria. Okay, so there are some techniques for the prioritization. So one of the technique called Moscow. So M is the must have, S is the should have, C is the could have, and W is the won't have. So based on these criteria, you can actually identify the total number of requirements and segregate them, like which is more important and which is less important. And there is also a graph, like how the needs and risk of failures is working with the Moscow model. So yeah, and what is the needs here? The needs of the requirements from the operational view, and the risks are if it is not important, what are the risks? So these are the two things you have to understand when you are prioritizing the requirements. Any question here? Okay, there are some other techniques. Is called single criterion classification. This is pretty much same with the Moscow, like mandatory, optional, and nice to have. So based on these categories, and of course, it is not like how you are feeling. This is the stakeholders and the other engineers have to be agreed upon in this situation. So this is not like a single person implementation, it is a team implementation. There is a Kano classifier as well, and it has a nice graph, but I personally do not like the Kano classifier, but many lecturers or many writers actually like the Kano classifier. Okay, then this is another technique. This is quite same as like, have you done before matrix method? So matrix method, normally it has like column and rows, same like this, and here this is don't be really confused with the mathematical model here. It's really easy. So here the benefit, it has I think minimum 1 to 9, but normally in metric method we are calling 1 to 5, and yeah, as a team, you have to decide, you have to give the points, and end of the day, you will find the prioritized numbers. And also there are some other tools. They also have this kind of metrics, quality function deployment. Have you heard about this? Maybe QFD. Oh. So that also used. So one lecture I will also discuss the QFD. QFD is quite big topic, but I will try to summarize short, in because this is important to learn. It is not only for a requirement engineering, rather than for making any kind of decision. Okay. This is actually the traceability graph, what I was talking about before. And this traceability graph you can make into the SysML diagram. If you have the diagram, you can make this one very easy. I think Savina also showed this one. And there is also some kind of guideline. Let's say when you are making the requirements, let's say one version to another version. So there are also versioning guideline, like small changes will be like 0.1, 0.2, and big changes will be version 2, something like this. So these are the methods, like you have to, it is not you have to, I think it is better to follow, because then the whole team will have a common understanding. It is also makes sense to me, like yeah, if the big increment is 1, and if you are thinking like the small one is like 0.5, that is also works. It depends on the users. So if you change the requirement, how you gonna react on this? So normally you have to analyze the impact if you change one requirement. So this is the situation. Let's say you have I don't know, 100 requirements, and one of the requirements you would like to change. And in this case, you have to identify what's the impact of this requirement change. Then you have to evaluate what the other parts will have the impact on this change. And then one part is approved and reject change. So if you see this is too complicated to change one requirements, because the other parts have influence on that, then you have to think over. Yeah, this is a small guideline if you wanted to change something. And here is the description. I'm not gonna describe. It is self-explanatory. And if you wanted to change the requirements, then you need to create a change board who gonna approve those requirement changes, and they will also evaluate um, the requirement changes and the impact of the change. Yeah, so this is just a small, okay. And this is the change information. What are the information you need to put into the change information, because you also need to have a document there, and those documents also have the identifier, title, description, justification why the change is happening, and when the date is filed, who is the applicant, and yeah, and the importance of the change requires, like, based on the applicant, what is the importance, or why he is giving this one the priority, that has to be analyzed. And the main reason behind this, that the change board could take proper decision on the changes. And yeah, this is the last slide. Well, there are some tools, and it is not one tools like I found recently one book. This book actually, I think more than 60, 70 tools he described based on requirement engineering, like what are the tools we're gonna need during requirements engineering. And the tool supposed to ensure the or satisfy those different views. So project view, user view, product view, process view, and technical views. So yeah, this is all about the requirements engineering tools. And I think my time is up. Thank you for your patience. And I think it's too many slides for one day. Uh, I know it's a little bit hard, but if you give some time at home, I think it won't be so difficult to understand. Thank you, guys. See you.